Hello, everybody, and thank you for coming for today's event. Hopefully, today you will find a lot of new technical tips for you that you can reuse later in your projects. And I want to take you into the trip over the latest features that we had released in this year. And let's also look in the future and see which features will come in the near future in AnyLogic. So let me share my screen. So at first, let's quickly go through all the technical features that we have that we added this year. First of all, we improved the IDE performance of our AnyLogic, and now it is much more easier and much more smooth to work with very large scale networks that you can frequently see in your big models, in your big projects, when you want to recreate the real facility like ports, like the entire factories and all this large stuff. Also, we decreased the possibility of running into 64K limits of Java when you're working with these large-scale networks. And let me also go very quickly through the other technical features that we added. Those are the support of Java 17 that brought a lot of a lot of stuff to write code more easily, just in the few lines instead of very large, very long expressions. And we also added the memory dump. Sorry. We also added the memory dump analyzer that allows you to quickly find the bottlenecks in your model, some places that consume a lot of memory that makes your model to run slow or even to stop in a predictable moment because of memory leakage. So now with memory dump analyzer, you can quickly find these problematic points and eliminate them from your model. And also I want to highlight here that AnyLogic supports the Mac ARM platforms so that you can use its very speedy and very powerful possibilities to run your models even faster. One of the most significant technical features that we added this year was the changing of ALP format. So now you can have the most structured way of storing your model. Before, we have the only one XML file with a lot of stuff within it. So all the agents, all the agent internals, all the network elements, all this stuff was inside one whole big file. And it was really pain when you have a lot of changes from different team members in this file to merge it. It was even impossible. So now we have LPX format that allows you to store all these elements of the model in the neat way. So here we have the internal structure of the model and it's more or less represents the view of the model tree that you have. So as you can see here, all the agents that you have in the model, they have their own folders. And inside these folders, we have all the files that represent the like the detailed info about this agent. It can be functions, it can be different property setup, and so on. So to use this new LPX format, you just need to switch to this new option when you create the new model or when you save your model. So let's see how it works in reality. So when you create the empty model, we have only like very basic folder and some the file with the file like auxiliary file that will recreate the model, binding all the files that contains information about agents and networks together. This file is called ALPX. And after that, we have if we enter the LP folder, we can see that inside we have the folders of the all agents that exist in the model. But right now, I do not have any agents besides the main. So if I go inside the main agent, I can see the XML file that represents the main agent and all the information that I have within it. So so even if I have the information about if I have some image or something, it also will be saved within this folder. So for example, if I have the network, the full network, it also will be represented within the specific folder that contains all the stuff about the network. Here we have the levels folder, and inside we have the specific files that contain all the info about these nodes, these paths, these intersections, and all this stuff. So when I added one other agent, at the same time, there is one more folder that appears within our structure. So here I have the patient folder as well. And inside this folder, we can see some code folder that contains all the events that I have specified for this agent, all these like functions, all these actions, all this code that I have for this agent. And also I have the description of variables that I have here. And also I have the information about the network elements or markup elements if there were any of these here. So now why we created this new format for AnyLogic, why it was so like difficult to deal with the ALP format that we have for years before. The main reason here is that we have a very long awaited request from our users for the support of teamwork. And probably one of the most popular version control systems that are frequently used in the development teams is Git. So now we also added the Git support within the AnyLogic, and so you can only switch to the Git view, and at the same point of time, you can reach all the specific stuff, all the functions, all these things that like Git users are familiar with. So you can see like repositories, you can see all your branches here. So you can take the new repositories, new projects, you can drag the models that were created from by other users from your team. You can see all the history that your model or your the project that contains a lot of models, all the changes that it came through in the history view. And of course, you can see the internals of the model in the specific view, and you can see all the changes that this particular version of your model has. Okay, so for the newcomers in Git, the Git is, as I told already, is a version control system where you can store all the changes that your model is coming through. It is especially useful when you work on the model in team. For example, one of your team members is creating network and another guy is creating some agent. So as we could see here, there was Jeff and Tyler who worked on the same model, and there was some changes that Tyler added because he created another branch from the original model. And so at some point of time, this branch with these changes can be taken in the original model. And so we can see all this history of all these changes, all these all these changes, all this alteration that our model is going through in the history view. And also we can always return back to any change if we understand that there was some problem. To discover the changes in detail, we always can click on the commit and see what really was changed there, because all the code of the model we can see here. And before it was really a big pain if you had only one big LP format, and now it will be much more easier because you do not need to check like dozens of thousands of strings here. You can just focus on your, for example, on your function or on the specific agent that was changed for another guy from your team, or that you changed, for example, 2 days before. We also can filter repository by file and explore who changed, as I told before, who changed this file, when it was changed, and what was changed inside. And another one big technical feature, new feature, is the support of new databases. As we all know, it was always possible to connect to any database through the JDBC support driver inside the AnyLogic, but of course our users had to know how to do this, to write all the dependencies within AnyLogic to find this particular drivers. So now we made it much more easier and add built-in support for the most popular databases like MySQL, PostgreSQL, Oracle, and MariaDB. And so now you can just choose these databases in the database import wizard or in the database connectivity element, and just set all your database name, login, password, and has a quick access to your data. Indeed, we had a lot of changes, very deep technical changes in AnyLogic this year. And we hope that these new technical patterns will come into your everyday routine while working with AnyLogic. But let's look what we also added and what we also improved in our material handling library as a headliner of our libraries. The first thing here that we are proud of is that finally we found the silver bullet for incorrect distance error that we had in the models with the very large and complicated conveyor networks. And so far, there are no problems with these with such models, and so all our users can create their large complicated networks without any troubles. As a constant improvement of performance, we also tuned up the research for our transporters. And let me stop a little bit on the two major features of the latest release. And the first one here is the maintenance support for conveyor stations and cranes. Some of our users who already use downtime block in process modeling library for resource pool, they already know it. And this block is widely used to model plant maintenance, failures, and the stuff like this. And now it is also possible to attach it to our material handling markup elements. So you can very easily set the like repairment process, like failures, like maintenance of your material handling equipment. And another big feature that we had in the latest release was the manual transporter movement. This is a very long awaited feature for our users. And originally, we always needed some flowchart blocks to control our transporter. And sometimes it was not so convenient because sometimes we do not have the agent and the loading point at the time when we want our transporter to move to it. Or sometimes our agent even doesn't exist because, for example, it's being assembled somewhere, and we want for our transporter to come to the loading point beforehand. So let me dive into this feature in more details. So first of all, I would like to present the downtime of the conveyor station. So here I have the very simple model with the conveyor station here. And in this model, I have the very simple conveyor station that process the batch of three agents at the same time. And I have some planned maintenance for this station. If I go to the maintenance block, I can see that I have the total time between occurrences, between the triggers of this maintenance for 30 minutes. Probably it is not like a realistic one because probably it's too frequent for real life. We decided to take this one for demonstration purposes. And also, like in a real situation, I also can set here other triggers like working time between the maintenance occurrences or working cycles between these occurrences. I also can have like schedule that will help me to plan my maintenance and stuff like this. Another thing I have here is the possibility to set which type of downtime I actually have. It may be simple delay. I also can have some sort of resources that will go and perform, for example, repairment or maintenance. Also, I can just stop the work of my equipment for some unpredictable moment of time that may be useful for the cases when you need some repairment, and the repairment is described by another flowchart. So here I also have priorities, but now I will leave them as they are to show how how this maintenance is intervened with the usual work of the station. And just for demonstration purposes, I have the event that will oppose the execution of my model at the same times as my trigger for the downtime is firing. So let's run this model. So I can see that my station already processed a bunch of items, and after that, my trigger fires. At the time, there was no agent on the conveyor, no agent on the station. So immediately the station just went into the maintenance state because there was no problems with it at all, like with entering the state at all. So let me speed up the model. One more point here is that while my station was on the maintenance, there was some agents that came on the entrance of the station. But what happens here? Because my station is on maintenance, it cannot accept the new items. So they are standing on the conveyor and waiting until the maintenance is finished. So as I will see, over some seconds, my station will entering the usual state, and at that point of time, it will accept new agents and start processing them. So it completely returned to the working state, and we can see, I will strip it up the model, and we can see that over time, it's just processing and waiting for the agents as usual. So now I have the next moment of time when my trigger fired, but here we have very different situation. Here we can see that the station was processing at the time when the trigger worked. So because the maintenance is not critical, like critical situation, it shouldn't interrupt the work of the station. My station will just proceed with the working on the agents. And at the point of time when the agents were processed and when they were released, only at this point of time, station will come into maintenance state. Of course, in reality, we have different situations, right? So sometimes we can have a very critical failure, for example, the breakage of some important part, and we need to stop the execution of the station. Like we need to stop the process of on the station immediately. So to make this working, I need to set the priority higher than the original priority of the usual work of station, that is 0. So here I have the priority 1. You can set here 10, 20, whatever you want. And I also need to choose the option of preempting other tasks. Because if I do not preempt, I assume that the station can proceed with the current work until it can proceed with the current work until going into repairman state. And also one more interesting feature that I wanted to show here is the possibility to work with resources. So let's assume that for repairment, we need our worker and we need them to move to the station or to not near the station where it will perform the repairment process. So, and one more thing I need to do in my model, of course, I need to add this failure as another possible downtime for my station. So now I will start the model again. And as I can see, at first it's going into maintenance as before. And after some point of time, okay, here we are. So the station was failed, and there was several items that were processed at the same time. So they just stuck on the station. Of course, in your model, when you have some custom logic, you can always take away these agents, take them to some other process, whatever you want. Just here, they're just stuck on the station, and they will need to wait until the repairment is done. And also, we can see here a little guy, and he left his home location just to perform the repairment process here. So this is the possibilities that AnyLogic gives you out of the box. And again, the downtime block is very flexible. It has a lot of different settings that you can tune up to represent all the downtimes, all the problems that you have, that your equipment can come into your real facility. Okay, let's move to the second feature here. And here we can see our transporter. And in this simple model, I have like the very basic flowchart where my transporter needs to move the agent from the conveyor to some kind of storage. So originally, as we can see, the transporter doesn't move to the conveyor, to the agent until it is ready to be loaded. So in this case, until it reached the end of the conveyor. But recently, we added the new feature that allows us to change this behavior. So we need to find the move function of the transporter API and set our transporter the destination where it needs to go. So in my case, I want my transporter to come to the loading location before the agent arrives to the end of the conveyor. So I'm calling for transporter. At the time, I'm starting the processing of the agent on my station. So let's see how it works. So as we can see, transporter started to move before the agent reached the end of the conveyor. So by the time the agent will reach the end of the conveyor, our transporter will already wait for it there. So very useful for the frequent range of cases that we can see in the real facilities. We think that this is probably the most common case when we need to use this function, this new method. But another method when we another case when we may need it, this is the simultaneous transportation and processing of the agent that we may have in our model. So here I have a very simplified model where I have the agent that need to be inspected by the couple of robots. And I want to model this process rather than use the simple move by transporter block and create some fake copy of agent that will go through this like scanning process. So now what I can do here, again, when my agent is starting to being scanned, if we want this agent to be scanned and travel on the AGV at that time, I can simply use this move function to make to model these simultaneous processes. So if I see if I run the model right now, we can see how it can work. So as before, we can see that our transporter arrived to the conveyor before the agent is ready, and by the time that agent entered the move through scan block, our transporter started moving. But wow, what is going on? Why our transporter is not carrying the item? Why item is still on the conveyor? The thing that is hiding behind this is the reason behind this is that our our AnyLogic cannot understand what you really want, why you really want to move the transporter. Whether you want to like change its location because it needs to wait for the agent until it's be processed, or whether you would like to perform the movement of the item. So to make it more evidently, we need to specify the state in which our transporter should move. So, so if I specify the delivering state in which transporter should move by the move command, it will understand that it should carry the agent on its top. So as usual. So the two main things we need here, I want you to remember these two main things that we need here to deliver transporter, to deliver agent in the manual control is the connection to the AGV or to your transporter in the sys transporter block, and the usage of the special state of the transporter. Of course, you can also use some other states if you would like to gather the appropriate statistics. But only this delivery state will allow you to see your agent being transported by the transporter. So if I run the model right now, I will see that it will go very smoothly. So as we can see, the agent is being transported by our AGV. Okay. So that's were the major features that we had in the latest release. And now let's move to what we have for the future releases. So let's spy through the keyhole into what our developers are preparing for us. The first thing is the very big new feature that all of us waited for probably ages. This is the robotic arm. And we all know that without this new element, our material handling library cannot be recognized as completed. So finally, we are proud to represent this new feature. As usual, our new element comes in two elements. The first one is the block, and another one is markup. And here we have quite unusual approach to setting the robot work, and we set it with the process time, like the time of the robot's operation. Why we decided to do so is that we would like to make a simulation model. We are not like robotic engineers, and so for our purposes, it's not so important at which exact angles our axes are standing, or at which speed they are moving. Rather than that, we prefer to understand the time that it takes for our robot to perform a certain procedure. And this work time is containing movement to agent and servicing the agent. And servicing process can be represented in two different types. The first type is the transportation process, when our robot needs to take item from one place and move it into the other place in the space. And the second type is the simple process of the agent without changing location. So it can be a welding process, it can be painting process or gluing process. When the end of effector of our robot is moving around our agent, but agent remains on the same place over the whole time. For the first release, we have only one alternative to set the movement of agent, and it is the movement from start point to end point. And we also have the possibility to set the movement to some predefined location after the operation of robot is done. As I told before, we're more concentrated on the time it takes of robot to perform its task, but at the same time, we all understand that we want to have realistic behavior of the robot. And like the most significant part here is the movement of the set of links at the same time. And so as you can see on the video on the slide, we considered these specifics of the robot, and every time it needs to move, it moves several links so that the presentation of the robot is very realistic. Also, there are a lot of different robots of different configurations that exist on facilities. They all very different. They have different sizes. They have different forms. And to help you to configure it, to make it more, to make it look more like the original robot that you have on your facility floor, we added the possibility to configure it to change the length of the links of the robot. Also, we add the management of end effectors. So here we have the gripper, and we can see it on the slide. And in future, we are going to add some other end effectors, predefined end effectors. But in case if you have very tiny end effector, for example, like some scanning tool, some optics, you can just unset the end effector from the robot, so it will have only the last joint, and that's all. And the final point I want to highlight here is the different restrictions that may exist for our robots. The first one is the very similar to what we have for jeep cranes. It is the blocked area. And another one is the arm reach distance that can help you to model the industrial cages where the robots that have very long length of all arms have to operate in more narrow space, not to touch other equipment outside this cage. So by specifying the arm reach distance, you can define the furthest distance your arm can reach. We have a lot of ideas in our bucket on how we can improve the robots. Now I just quickly went through the like most significant features that wait for you in the first release of the robots. But we always open to your feedback and to your reaction. So if you're interested in this feature, please contact me directly and you can become the alpha user. You can try this feature by your own hands. And if you have any expectations, any feedback, any wishes for this new functionality, you can share it with us and we can add it in the future releases as well. As I told, with robots, the CARM added, our material handling library can become completed, but it doesn't mean that we do not have any ideas on how our current elements of the library can be improved. And the first point that we would like to enhance here is the maintenance. So we would like to add the maintenance not only to equipment that I mentioned before, we also want to add it to our transporters so that our transporters also could go on the maintenance that can, for example, represent the charging, the planned charging or opportunity charging, and so on. We also would like to add the possibility for automatic movement to the maintenance location, again for transporters and for other moving resources, for example, cranes and dynamic process modeling resources. Another very large element of material handling library that have a lot of features that will be released soon is the storage component. And here we want to add the possibility to perform store and retrieving tasks using the set of resources and using some resources that were already seized before the actual storing or retrieving process started. It may be useful, for example, in the cases when you had your AGV, transporting the agent from some station to another station, and after that, only after that, you need to take it to the storage. Also here, we want to add the new type of configuration of the rack that is very frequently seen in the real storages. This is so-called mixed configuration, where we have two single bay, two standalone racks at the sides of the storage and the back-to-back racks in the middle of them. And we also want to add the possibility to set to generate the certain amount of agents within the storage on the startup of the model. And the final point here that we also want to add in the recent future is the tugger trains. This is the special type of transporter that not carrying the item on itself or on the special wheels, but instead of that, it's towing the agents, the cargo behind them in the trainer-like form. And the most interesting point here is that these trailers that like following the tugger, they repeat the trajectory that is being made by the tugger. So now it is very hard, very difficult to make in the AnyLogic manually. So we are going to add this out of the box. And another this is like the first point we want to focus here. And another interesting point that we want to focus around the toggle trains is the possibility to deliver the items not only to one target by to the set of different targets, as the real toggle train can do. Of course, the material handling library is the headliner of our changes. All big changes probably are coming there, but we're constantly improving all other libraries as well. And this year, we have like a very, a very large amount of changes, of small changes in the road traffic library. The first one is quite straightforward. We are just going to include and exclude several rows in the car route, so it will be easier to set the logic when you need your car to pass by some congested part of the road network where you have a car accident or traffic jam, and you won't need to split your flow chart in the set of car move to blocks. And another element that has a lot of different changes here is the parking lot. So we are adding diagonal parking. We also adding the possibility to specify the particular parking place in the whole lot. So you have more control over parking process than before. And the final interesting feature here is the priority, is defining the priority for exiting parking. So as you know, originally our cars that are leaving parking places, they always waiting until there is some very big gap on the road, so not to obstruct the cars that are passing by. But in reality, sometimes when we have like very huge parking, for example, near the shopping center, and the traffic speed on this parking lot is very slow. Drivers allow other drivers to leave their parking lots, because if nobody do this, sooner or later, all the parking lots and all the parking places will be filled up, and there will be no free space for the new drivers that are coming. So now you have control, and you can define whether the car that is leaving the parking lot is more important than the one on the road, or vice versa. Another feature that we are working on right now is the possibility to provide the lane control. And this feature is coming into two functionalities. The first one is the possibility to immediate change of the lane by the API call. For example, if you want your car to change the lane because the original lane is blocked with traffic accident or with roadworks. And another functionality here is the possibility to set the preferred lane for a particular car type. For example, it can be a tractor or a trailer or truck that should move only on the first lane and cannot go to other lanes. And vice versa, it can be used for the emergency vehicles that always prefer to run near the median line, so in the fast speed lane. And we started with some core improvements that we had added this year, and let's finish with the core improvements as well. So here we can see that we are going to add the model profiler that will help you to find the bottlenecks of your logic model logic, so you can find which functions, which code is consuming the most of your resources, and it will help you to optimize your model so that it can run faster. And another very, very big feature that we are all waiting for is a connection to NVIDIA Omniverse. We will have the more detailed presentation about it in the several hours. So please check your schedule, and I would recommend definitely to see it because it should be something fantastic. But for now, let's have a very tiny spoiler. And what we can see here is that AnyLogic will allow you to render the 3D scene that you already have to get the USD scene in Omniverse. It will already have some nice shades and lights, and so already it will look more realistic than the one you can create in AnyLogic. But if you would like to create even more realistic, even more detailed scene in Omniverse, you can do this. And you can just bind it to the model in AnyLogic that only have some brains in it. For example, that only specifies the movement of the agents, their creation, and so on. Okay, so the most interesting question, coming to the most interesting question, guys. When can you wait for all this feature to come out? So, and good news, we have very fruitful, very promising autumn this year. So we are going to see a robotic arm. We are going to see the new changes of road traffic this year. And we are also going to see the NVIDIA connector as well. And all other features are going to the first half of 2025. Here we have the model profiler. We have the improvements of maintenance. And all other features, mentioned features, will also be released in the next year, hopefully in the first half, but it is hard to predict right now. So, but just to once again to wash through them, you can see here that we have tagger trains, storage improvements, and some other enhancements of road traffic library. So thank you very much, and I'm ready to answer your questions. Okay. Let me see what I have in the chat. Okay, there is one question from Jacoben Solo Voslo. This is by, do you mean the CPU performance profiler? Because we already have the memory profiler. Yeah, this is like quite common question because it's profiler, and I understand that it may be a bit confusing. The first one, the memory profiler that we have is more about the consuming of the consuming of the memory. So it's more about memory leakage. And about the performance profiler, yeah, it is more about how much computational resources your CPU, from your CPU, the particular function takes. So it may not consume so much memory, just it works for longer time. So you can see this by using the new profiler that will come next year. Okay, another question from Ben. Do you plan to pre-configure some of the most common robots out there? May be useful as a starting point for users. Well, I would like to say that first of all, we researched for some most popular types of the robots, and we took the quite common lengths. We tried to take the most common lengths of the robots for our initial release. Actually, you can just take the robot that you have. That you have on your palette and put in the model, and it should work because it is like one of the standard robots like a lot of facility has. What about presets? Yeah, we'll think about it. So it is nice idea. Thank you, Ben. Probably we will add it in the later releases as well. Okay, one more question from Felipe Haro. Will the robotic arm have collision detection? For the first release, no, but we have such idea for the future. And we would like to contact you to discuss more in detail how you see this, because currently we think, because again, we are not robotic engineers, and we would like to focus more on the time that it may take for robots to resolve the collision with the other, like with another robot that is working nearby. So currently we have the idea of just adding some like certain stochastic delay for this purpose, or not to start the movement of the robot if we understand that the nearby robot is also working. But right now it's only the concept, so we will be happy to know all the insights of this of the actual process. Okay, quite tricky question, but let me answer this. Will all the backend development you do for AnyLogic 8 be implemented into AnyLogic 9 at some point? At some point, yes, of course. We are going to take all the features that we have in AnyLogic 8 to AnyLogic 9 at some point of time. But as we understand, some of them are easier to to take into the AnyLogic 9. Some of them are more difficult. So at first, of course we need to take all the basic, very basic like features from AnyLogic 8. And only after that we will add some advanced ones to AnyLogic 9.